Welcome to this explainer. Today, we're diving into some incredibly fascinating source material that proves your home isn't just a place to live. It's actually an active, buzzing chemistry laboratory. So let's jump right in. Okay, look at this question, because honestly, you might be surprised to learn that you're utilizing complex chemical reactions every single day. You know, chemistry isn't just about scientists in white lab coats mixing bubbling liquids in some sterile room. It's happening right now in your kitchen, in your bathroom, and even inside your own body. We literally use these invisible reactions to eat, to clean our homes, and to stay healthy. Section 1. Meet your everyday chemicals, the chemical personalities inside your pantry. Let's start by meeting the cast of characters hiding in plain sight, right there in your pantry. We're going to reframe some incredibly common ingredients that you probably buy at the grocery store without a second thought, and reveal them for what they truly are: powerful chemical compounds. First up is table salt, formerly known to chemists as sodium chloride, or NaCl. It stands as one of the absolute oldest and most useful chemicals in all of human history. That simple formula, NaCl, means that each tiny crystalline bit of salt is made of just one sodium atom tightly bonded to one chlorine atom. Now, what's really mind-blowing here is the sheer versatility of salt. It isn't just for sprinkling on your fries to enhance the taste, right? For thousands of years, people have relied on it for preserving food. It works chemically by literally drawing the water out of meat and fish, which dramatically slows down the growth of bacteria. And think about wintertime. When road crews spread salt on icy roads, they are using chemistry to lower the freezing point of water, forcing the ice to melt, even when the temperature drops well below zero. It's even used as a base ingredient to produce other chemicals, like the sodium hydroxide used in making soap. Pretty amazing for something sitting on your kitchen table. Next up, we have a true multitasking hero, baking soda. Scientifically, we call this sodium bicarbonate. If we look at its properties, it acts as a mild base, sitting at a pH of about 9 on the scale. And because of those basic properties, this single chemical can do an astonishing variety of jobs around your house. When you're baking, and this base meets an acid, say buttermilk, it produces carbon dioxide gas. Those resulting CO2 bubbles get trapped in your dough, giving your muffins and pancakes that perfect fluffy texture we all love. Beyond the oven, because it's mildly abrasive, you can use it to scrub tough stains right off your counters without scratching them. It also physically absorbs bad smells, which is exactly why an open box lives in so many refrigerators. And hey, if you dissolve a little in water, it acts as an antacid, chemically neutralizing excess stomach acid to settle an upset stomach. Talk about a real game changer. Our final everyday pantry character is vinegar. Now, unlike our base, baking soda, vinegar is a mild acid. Most household vinegar is actually a solution made up of mostly water, about 95%, with just 5% acetic acid mixed in. This specific ratio lands it firmly on the acidic side of the scale, with a pH of about 2 to 3. So, the crucial takeaway here is that vinegar's acidity isn't just there to add a tangy flavor to your salad dressings. That acidity is a serious chemical tool. Many people use it to clean glass because it actively dissolves hard mineral deposits and cuts right through grease. And just like salt, it's a legendary preservative. When you pickle vegetables, you're literally submerging them in an acidic environment where harmful bacteria simply cannot grow. Section 2. Water and powerful chlorine, the universal solvent and the ultimate purifier. As we step out of the pantry, we're going to look at two powerful liquids that keep our entire world flowing and, importantly, keep us safe from microscopic threats. First, we absolutely must talk about water, easily the most important chemical on Earth. With 2 hydrogen atoms and 1 oxygen atom forming H2O, it sits exactly in the middle of the scale with a perfectly neutral pH of 7. You know, scientists often refer to water as the universal solvent because it has the unique ability to dissolve so many other substances. Think about when you mix sugar into lemonade. Water is doing the chemical heavy lifting there. It carries dissolved chemicals through the global water cycle, from the oceans to the sky, and it does the exact same thing inside you. Considering your body is about 60% water, almost every single chemical reaction happening in your cells right now is taking place in a water solution. Then we have chlorine. Now, in its pure elemental form, chlorine is actually a greenish-yellow gas with a really strong smell. It is incredibly powerful. But when we use it in tiny, carefully controlled amounts, it is a vital purifier. It kills the germs in swimming pools so we can swim safely. Water treatment plants add microscopic amounts to our tap water, far too small to hurt us, but just enough to kill harmful bacteria. It's also the driving force behind household bleach, specifically in the form of sodium hypochlorite, allowing us to remove tough stains and completely decimate germs on our kitchen surfaces. However, because chlorine is so powerful, I need to be absolutely clear on this critical safety point highlighted in the source material. Bleach and chlorine-based cleaners are serious chemicals. They must only be used by adults and always in a room with excellent ventilation. And most importantly, actually, scratch that, this is literally life-saving. You must never, ever mix bleach with vinegar, ammonia, or other cleaning products. Doing so causes a rapid chemical reaction that produces incredibly dangerous, toxic gases. So please keep them separated. Section 3. The red cabbage experiment. Proving the invisible properties of household items. Now that we know our chemicals and respect their power, let's look at how you can actually visualize these invisible acidic and basic properties right at home using a DIY acid-base indicator. The source outlines a fantastic experiment. By taking chopped red or purple cabbage and steeping it in a bowl of hot water for 10 to 15 minutes, the water extracts a natural chemical from the leaves, turning a deep purple. You've just created a natural pH indicator solution. You then pour this purple juice into clear cups and add a spoonful of different household liquids to each one. When you stir them together, chemistry happens right before your eyes. A shift to red or pink means you found an acid. If it stays purple, the substance is neutral. But if the color moves to blue or green, you're looking at a mild base. And a bright yellow reveals a strong base. When running this test with common items, the results are honestly pretty striking. Lemon juice and white vinegar will instantly turn the liquid bright pink or red, proving they are, for sure, acids. Interestingly, milk will also turn a very light pink, revealing that it is actually slightly acidic. On the other side, if you drop in baking soda water or liquid hand soap, the purple juice transforms into a vibrant blue or green, confirming that these cleaning agents are indeed bases. It's like a perfect visual map of the chemical lab inside your kitchen. Section 4. Protecting your teeth. The daily chemical reaction in your mouth. Finally, let's bring these concepts intimately close to home. We're going to examine a vital, daily chemical reaction that is happening right inside your own mouth. Think about what happens when you eat, especially when you eat sugary foods. Your mouth naturally contains bacteria. As these bacteria feed on those leftover sugars, they produce acids as a byproduct. These invisible acids relentlessly attack the hard enamel coating on your teeth. If left unchecked, this acidic environment eventually dissolves the enamel, which is exactly how cavities are formed. But this is where your toothpaste steps in as an absolute chemical superhero. Based on everything we've learned so far, you can probably guess how it works, right? Toothpaste functions as a mild base, typically formulated with a pH somewhere between 8 and 9. So every single time you brush your teeth, you are actively deploying chemistry to the rescue. The base in the toothpaste directly interacts with and neutralizes those harmful bacterial acids, instantly halting their attack on your enamel. Furthermore, toothpaste contains fluoride, a specific chemical designed to physically harden and strengthen your tooth enamel, making it even more resistant to dissolving. This is the exact scientific reason dentists recommend brushing twice a day. You are maintaining a continuous chemical shield over your smile. As we wrap up this explainer, I'll leave you with this to think about. We've seen how salt preserves, how baking soda cleans, and how cabbage can reveal completely invisible properties. But if a simple paste on your toothbrush is a daily chemical hero saving your smile from invisible acid attacks, what other incredible hidden reactions are happening all around you, keeping you safe right now? Keep observing and keep wondering about the hidden chemistry lab you call home.